Okay, you only can use a calculator on the last two problems on tomorrow's quiz. The only time you can make up a quiz after is if you're sick. You guys understand? Going on a sports trip or whatever football, just do it before you. Okay, before I forget, let me pass this up. This is polynomial 6 and 7. Get rid of the other two and replace it with this. This is the revised version. Just 6 and 7 long. So Okazaki, when are you going to do it? There you go, see? You need a calculator for the last two problems. You're bowling. There. Replace the other two with those revised editions.
Alright, thank you.
And tomorrow's quiz, you need a graphic calculator, you know.
Okay.
You're going to have to calculate zeros and maxes of bins. Okay, what are we on? 3. Because 3 is the one with the word problem, so there shouldn't be too many problems. Number 1, only 2 questions? That is fantastic. Well, watch, after I finish number 1, I'm going to turn around and have more problems up there, I know. You guys don't remember doing these problems last year? I hope you don't tell your calculus teacher next year the same thing. You're going to get these exact same problems, except instead of using your calculator to calculate the max and mins, you're going to use calculus. Okay, we're going to cut corners from an 8.5 by 11 sheet of paper like this. So this is 8.5 by 11 inch sheet of paper. You're going to cut these corners away. I remember seeing this in your book. And then you're going to fold up the flaps like this, and then you're going to get a box. Now, does it sound familiar? Okay. It says, how big a square should be cut from the corner so that the volume of the box is the maximum? So what are we trying to maximize? The volume of the box. So you have to write the volume as a function so that you can graph it on your calculator, right? So if we look at this, what do we call x the side of the square that you're going to cut away? Therefore, when you fold up the flaps, what are the dimensions of the box going to be? It's going to be this, right? What is this right here? 11 minus 2x. What is this? 7 halves minus 2x. Okay, no calculator. You want to work with fractions? Oh, you can. Yeah, but it doesn't matter because you use a calculator. And then when you fold up the flaps, what's the height of the box going to be? X. So the volume is going to be length times width times height. So it's going to be 11 minus 2x times 8.5 minus 2x times x. And graph it on your calculator. And are you guys practicing? You can't just press the graph button. You gotta set the window so you can see the hump. Morrissey, question.
Mine is being like really weird.
Okay, well, first of all, okay, Mr. Park, what do I make x min and x max and y min and y max? Well, that's what you gotta get. That's what you gotta practice at. Now, what is the domain of this problem? This problem only makes sense when x is greater than 0 but less than. What's the biggest x can possibly be in this problem? 4.25. How come? Because look, how can you cut? Isn't 4.25 half of the side? How can you cut more than that away? Or how about like, if you plug in a number bigger than 4.25, then this becomes negative. How can one of the sides be negative? And what does y represent? Y represents the volume, so you kind of have negative volume. And this is where you gotta just guess. Try 10. If that doesn't work, then try 100, then try 1,000, and so forth. So is it still weird? Your goal is to, see, here's your calculator screen. Your goal is to see a hump like that so you can calculate the maximum. Are we seeing the hump? Oh, there's the hump. Something's wrong. Okay, check pressure why you can plug that. Did you plug? Where? I don't even see a pi in there. There's no pi.
Sorry,
Oh, by the way, that pi problem, isn't nobody's going to ask about that, number 3? It all came out on your calculator.
No.
Oh, I got a different answer.
Woo! Good thing somebody asked before. I don't see number 3 up there. So moving on to 7. You guys don't want to clear it up before tomorrow's quiz, or just all get it wrong then?
Did you clear it?
Oh, you want me to clear it up now? Okay. Number 3. A rectangular sheet of paper like this, with perimeter 50, is rolled into a cylinder. Like that, like this. Okay. If x is the circumference of the base of the cylinder, so isn't that this? And if the perimeter is 50, doesn't that make this 25 minus x? Write the volume of the cylinder as a function of x. Now, what's the formula for volume of a cylinder? Pi times the radius squared times the height. What's the height of the cylinder? That's easy. 25 minus x. And now, what's the radius? How do I figure out the radius of the cylinder? Well, I know the circumference is going to be x, so what equation can I write? 2 pi r equal x. Therefore, r equals x over 2 pi. So x over 2 pi. And then when you simplify this, you get pi times, and remember, when you square a fraction, you got to square both the top and the bottom now. Times 25 minus x. So this pi cancels that pi, so you got x squared over 4 pi times 25 minus x. Now, how did you punch this in on your calculator? What did you do? y1 equal love. You said you didn't get your answers. How do you punch it in on your calculator? y1 equal what? What? Oh, parentheses like that then.
No, no,
Parentheses there. Yeah, okay, that would work. Who else didn't get the correct answer? There's only one then. Why are we doing it?
Does it matter like how you roll it?
No.
Maybe I understand.
But, because it doesn't, what do you mean, how, what?
Like that or like that? You're like that.
But it says right there, x is the circumference of the base. X is the circumference of the base. You got, like I tell the math people, when all else fails, read the directions. Read the problem. You guys know that when you punch this in on the calculator, you cannot just go x squared over 4 pi, right? You guys know that, right? Because what your calculator does order of operation. So when your calculator sees this, it's going to do x squared divided by 4, and then it's going to multiply it by pi. So if you want the 4 pi in the denominator, you have to do that. Oh, I'm glad I did that for nothing. Okay, Morrissey, did it come out now? The hump,
Yeah.
Did the hump show? Okay, and then finally, number 7. Oh, so you guys got the rest. This is a smart class inside. A right circular cylinder is inscribed in a right circular cone. So we have a cone, and inside you're going to put a cylinder like this. Like that. With height 10 and radius 5. The base of the cylinder is parallel to the base of the cone. Duh. X represents the radius of the cylinder. So this is x, and why don't we call that h for height then, whatever. write the volume of the cylinder as a function of x. So again, what's the formula for volume of the cylinder? Pi times the radius squared times the height, but we can all use the radius is x. Okay, now here's the hard part. How do I figure out what the height is in terms of x? How many people got it? Now what did you use? Radius.
Well, there's similar triangles.
Similar triangles. We have to know similar triangles. Duh. You don't know how you guys have no idea how important that is in calculus. Okay, so maybe how can I draw in lines to get similar triangles? Here, like this. So right there are 3 similar triangles. You got the baby bear up here. You got the mama bear over here. And then you got the papa bear over there. Can you see why they're all 3 similar? So you got the baby bear, the mama bear, and the papa bear. You can use any 2 out of these 3, it doesn't matter. Now of course you probably want to use the papa bear because in the papa bear, isn't this just 5 and 10? Okay, now look at the mama bear. What is this and this? No. If this is x and this whole thing is 5, isn't this 5 minus x? So in the mama bear, isn't this h and 5 minus x? And then in the baby bear, this is x. What would this be right here? If the whole thing is 10 and that's h. Wouldn't that be 10 minus h? So in the baby bear, you're going to get 10 minus h and x. Now you can use any 2 out of the 3. It doesn't matter because it all comes out the same. Which is the best 2 to use? Baby and mama, baby and papa, or mama and papa. Just look at it. It doesn't matter, but there's one that's the easiest. Okay, I'll give you a hint. Papa, because it's only got numbers, yeah. Papa and 50-50 chance. Mama. Mama. Just look. Okay, if you use these 2, you get h over 5 minus x is equal to 10 over 5, right? But if you use the baby and the papa, you're going to have 10 minus h over x is equal to 10 over 5. Which one is easier to solve for h? This one, because to solve for h, you just multiply by 5 minus x, you do get 2 times 5 minus x, finished. But in this one, if you have to solve for h, you're going to have 10 minus h is equal to 2x, h is equal to 10 minus 2x. You've got to go an extra step. That's called foresight. Can you see that it doesn't matter? They both come out the same. Oh boy. So 10 minus, should I just put 10 minus 2x there? Okay. And then now, can you guys graph it and get the hump on the screen? Tomorrow you're going to have to prove you can do it. Do not, well you can try. Try press the graph button and see if you see anything tomorrow. Set the window. You want to set the window. Like in this problem, what should you make x min and x min? You guys got to practice this. Obviously, okay, in these problems x min and y min are always going to be 0. Now, in this problem, what is x max going to be?
5.
5, because if x gets bigger than 5, then this distance becomes negative, right? What should I make y max? This is where you got to kind of guess. Well, start with 10, if that doesn't work, try 100, 1,000. Yeah.
Wouldn't you just make it
Just make it super big.
Yeah.
Okay, the problem with making it super big, stop making me drop my paper. The problem with making it super big is if you make it too big, then when the graph is drawn, it looks like this. Especially when you have, if you have make the thing bushy like this. You don't see anything.
What if you just make left bound 0 and right bound 10?
What?
'Cause-
Yeah. No, but I'm saying if you make y max too big, then when the thing graphs, it's going to graph it like this. Oh, okay, yeah.
Yeah.
Oh, you understand what he's saying? Even though the graph is just like so close to the x-axis you can't see it, you can still calculate the maximum by, because when you move along here, it gives you the coordinates as you move along this way. You know what he's saying? Yeah.
But how do you know where the vertex is? Like that.
You gotta look at, so when you do the left bound thing, you know when you're moving the left and right arrows, when you're moving it like this over here, it shows you the x and y coordinates, right? So what you do is you look at the y coordinates, it's starting to go up. Once it starts to go down, then you know you're on the other side of the hump, right? You know what I mean? So yes, even though you don't see it there, yeah, you can do it.
Yes.
Wouldn't it be just easier to just make it so you can see the hump? And what about the prism people? Do you have to see the hump on your screen for the thing to work?
No, you do.
No.
Oh, yeah, on the screen.
It has to be, the top of the hump got to be on the screen.
Yeah.
How come some people say no and some people say yes? So even if it's not on the screen, if you press the max button, it'll give you the max. Or just the max that's on the screen. You guys better find out before tomorrow.
We can do it. That was
It
maybe
It doesn't do it.
Okay, so is that it? We're done then. Okay. Okay, here we go. Today, what are we doing? Ooh! We're learning the rational roots theorem. Okay, here is your Algebra 2 book from last year. I'm just going to randomly pick a problem. So what you need to do tonight is we need to be able to solve a polynomial equation by factoring it. Okay, where is it? In fact, we did this in Algebra 2b. Right there. The zeros of a polynomial function. Okay, pick a number between 57 and 68.
59.
Between 57 and 68.
You said
60, I heard 63. Ah, that's so weak. No.
64.
Okay, 64. Okay, we'll do that. Ah, that's weak too, but whatever, we'll just do it. 64. Ah, never mind, I'll just pick the number. 67. 2x to the 4. Why am I even asking you guys? You guys just come up with nonsense anyway. Silence! X squared minus 64 plus 20 equals 0. Okay, here is a polynomial equation. Solve it. First of all, how many answers are there going to be? Why? Because what? No, but what's the reason? Because Mr. Rubash taught us that. No, that's even worse. We just talked about a problem yesterday. Remember yesterday we graphed the fourth power equation and the thing looked like this. How come we only get 2 intercepts? Because the other 2 are imaginary, that's why, remember? So, why are there going to be 4 solutions to this equation? So I heard somebody say it. Nakaki? The fundamental theorem of algebra. The fundamental theorem of algebra says if you have a polynomial equation of degree n, you will have n solutions. So there's going to be 4 solutions. And you know who proved the fundamental theorem of algebra? Without? Math team got to know these things. What? He's one of the 3 greatest mathematicians of all time. Remember I wrote the 3? Gauss, there you go. In fact, I just heard the word Gauss somewhere. No, never mind. That was like 20 years ago when we had some fish, one of the fish I named Gauss. Okay, now, when you have an equation that's third power or higher, you can factor. Remember how I showed you factor by grouping? Are you guys practicing that? No, most people don't like factor by grouping because you need foresight. So that's why we have synthetic division. So, how did we do synthetic division? We write down the coefficients, 2, negative 19, 57, negative 64, 20. Put the box, do. Now what numbers do I put in the box? Your goal is to pick a number so that the remainder comes out 0, right? Now how do I figure out what numbers to put in the box? Just pick anything.
Reverse it. So it's 0, and then go to 20.
Start with 0?
No, like on the right side. Like start with remainder 0.
Okay, what did we learn last year? It's called the rational roots theorem. If this equation has a rational root, then it has to be of the form, what did we learn last year? P over Q, where P is a factor of this number and Q is a factor of that number. Okay, what are the factors of 20? Okay, it's actually plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Well, I won't write the plus or minus, but it's there, right? What are the factors of 2? Plus or minus 1, plus or minus 2. If you take all the combinations of these numbers over these numbers, those are called the possible rational roots. You guys learned this last year, right? So, Kobe, you didn't learn it last year? P over Q? Okay, what are all the combinations of these numbers over that number? Okay, let's do it. 1 over 1. Okay, but now you write plus or minus 1. 2 over 1. No, plus or minus 2. 4 over 1. Okay, I'll just do it. 5 over 1. 10 over 1. 20 over 1. It's always plus or minus, people. Okay, now over 2. 1 over 2. So plus or minus 1 over 2, plus or minus 2 over 2, but that's the same thing as 1. Plus or minus 4 over 2 is the same thing as that. Plus or minus 5 over 2, plus or minus 10 over 2, which is 5, 10, 20 over 2 is 10. So this is it. This is called the possible rational roots. In other words, if this equation is going to have a rational root, it has to come from this list. So should I try synthetic division by 3 then?
No.
Why not? Because it's not on the list. Why would you try something that doesn't have a prayer of having a chance of being a root? You guys understand what I'm saying? If this equation has a rational root, it has to come from this list. 3 is not on the list. It doesn't have a prayer of working. These are the only numbers that have a prayer of working. You guys understand? Okay, so what should I start off at?
1.
Yeah, 1 is the normal place you should start. We start with 1. Okay, so here we go. 2. Go.
17.
What?
17.
40. 24.
No, we want the remainder to be 0. But, did you guys, I know Mr. Takeisa's students, they do this every year. When you do synthetic division and it doesn't come out 0, at least you can tell certain things. Like, by looking at these numbers over here, it can tell you whether you have an upper bound or a lower bound. Does that sound familiar? Go ahead, Mr. Takeisa. Upper bound, lower bound? What about Mr. Ruba? Doesn't matter, because I'm teaching you like you don't know anything. Now, how do you determine if this number is an upper bound?
Positive, negative.
Close. If you do why don't you guys read the notes? If you do synthetic division by a positive number, what are you looking for over here? No. All non-negative. 0 is not negative this way, right? So if all of these numbers come out positive or 0, then this number is an upper bound. What does that mean? That means there's not going to be any solutions bigger than that number. So then you stop. You don't try anything bigger. You know what I'm talking about? It's an upper bound. See, so what you do, this is a big list, that's why. You really want to try all of them? So what you do is you work your way up to the upper bound until you get to the upper bound. Then you work your way down to the lower bound. And then all the answers have to be in between there. Because synthetic division is a guess and check process. You want to like minimize the amount of time you spend on it. You know what I'm talking about? You don't want to just be spending 1 hour on this problem. You don't have it. Anyway, is this an upper bound?
No.
Are all of these numbers either positive or 0? No. Okay, so we go to the next one. What's the next one on the list? 2. So I tried 2. 2, 4, negative 15, negative 30, 27, 54. Oh, I'm sensing something. Negative 10, negative 20, 0. Okay, so that means x minus 2 is a factor. The other factor is this thing right here. Is 2 an upper bound?
No.
No. So what's the next number I should try?
3, 4.
Wrong and
5
wrong.
and a half.
What?
25.
Wrong?
2.
Well, it's up to
2.
you. If you want to
2
try,
again.
usually I save the fractions for later.
2 again.
2.
Yeah, 2 again. Very good, because it could be a double root, that's why. Right? So if you're just discounting the double roots, you're making a big mistake. So yes, I would try 2 again. That's what I would do, but you can try whatever you want. This is what you got to practice tonight. You got to be able to do this quickly. So negative 22, 5. Oh! So those of you who just going on and not even checking to see if it's a double root, you just missed 2. I laugh at you. So x minus 2 squared. And then, now you have a quadratic. Once you get it down to a quadratic, either you factor it or use the quadratic formula. What do you think? Does that factor or should I use the quadratic formula? That factors? Who said quadratic formula? Go to your room. Minus, minus. So therefore, what are the four solutions of this equation? X equals 2, 1/2, and 5. Yeah, but Mr. Park, when you see 3, that's a double root. The graph bounces off. That's why, right? You look at the graph. Did you guys call it a double root last year, or do you call it a root of multiplicity 2? Is that what you called it last year? Okay, whatever, I don't care. Just do it. Okay, now what about lower bound? Like, how do you know if a number is a lower bound? If you do synthetic division with a negative number, okay, here, let's just do this for fun, because someone, especially you guys from Mr. Rubash, you guys don't know. What if I synthetically divide by, let's just say -5? Let's just try it. Let's see what happens. 2, -10, -29, 145, ooh, 202, -1010, woo, -1074, oh my, 5,370. Am I doing this correctly or just nodding your head? Of course I'm right, I'm the teacher. So true or false, -5 is a lower bound. Yeah, because when you synthetically divide by a negative number, you're looking for alternating. Non-negative, non-positive, non-negative, non-positive, non-negative. And are they? Are they alternating? Yeah, so this is a lower bound. So once you hit a lower bound, there won't be any solution smaller than that. So what's the next number I should try? Should I try -10 now? No, because this is a lower bound. Don't try anything lower than it. That's why you have all of these tricks to help you, because synthetic division is guessing and checking. If you really want to go through all of these, you can, but so what you do is, this is what you do. You go up to the upper bound, go down to the lower bound, and then just concentrate your efforts over there, instead of just randomly guessing. Oh boy. Question?
But like, if you go all the way up to the upper bound and all the way down to the lower bound, wouldn't you have found like everything already? So it's like,
No.
oh,
No.
how come?
And oh. Okay, that's a good question. Okay, no, that's a good question. What if I go all the way to the upper bound, and I go all the way down to the lower bound, and I don't hit anything? What if, well, there's two things. One, you cannot add and subtract correctly. You cannot do arithmetic. What's the only other possibility?
There's no symmetry. Imagine.
Oh, there you go, Kobe. There are no rational roots. This is the list of possible rational roots. So if you go through this list and none of them work, what can you conclude? There are no rational roots. That doesn't mean it's imaginary, it just means it's not rational. Because you could have like radical 2, right? Or something like that. Yeah. So this is the rational roots theorem, not the real roots theorem, the rational roots theorem. So if you exhaust this list and there's no solution, you can't find anything, that just means there are no rational roots to the equation. You guys get it? See, last year you kind of went through it and it's all fuzzy, but now it's like clear, right? My critique. Okay, let me see tonight's homework. What else do you have to know? Come on. Come on! And then you got some word problems. Oh, you got a good word problem in there. Okay, I'm just going to teach you one more thing then. This is a common sense thing which is going to come up in problem, but I guess it's not that common sense. Number 3. Let's say you have a polynomial function. Okay, this is the x-axis. Let's say you have a polynomial function f, and here's 1 and 2. F of 1 is equal to -3. F of 2 is equal to 4. I'm just making this up. Why is it that there has to be at least one real root somewhere between 1 and 2? Yeah, because if the y-coordinate here is -3 and the y-coordinate here is 4, to get from here to here, don't you have to cross the x-axis at least one time? Yeah, so that's what you have to know in the number 3 problem. Unless, of course, you're Keenan Koga, and he goes, what, can't you just go around the x-axis like that? No! Well, for 2 reasons. The x-axis goes forever that way. Well, then I just go further. And even if you could do that, that's not even a function anymore. It doesn't even pass the vertical line test. Because, you know, one of the properties of polynomial functions are always continuous. There's no breaks in them, and they're all smooth like that. One property, and this is an important property of polynomial functions, they're smooth and continuous. They never come to sharp points. There's no breaks in them, no asymptotes, no pukas. Anyway, by the way, just seeing if you remember, last year, when you have a puka in the graph like that, what do you call that? Circle what? Open circle. Hold. Didn't you guys learn the real name of it? Puka, hold, open circle, 999. It's called a removable discontinuity. Hold. Okay, we're done. So tonight's homework, you gotta practice. Oh, by the way, I'm going to show you one more because you're just going to make me do it on the board. Let me do a problem like number 1A and 1C are almost the same thing except different.
Why?
Okay, here, let me do a problem like 1C for you there. Sign it. X to the 6. X to the 6. Shh. Shh. No, you guys can't handle that. No, you can't. Can you handle 27 and 8? Okay, what's 27 times 8? Quick.
1,650.
Just quick. 8.
260.
Think of that as 20 plus 7. 160 plus 56.
260.
Okay. Okay. This is just like problem 1C over there. How do you solve this equation? First of all, how many answers are there going to be? 6. What guarantees that?
6.
The fundamental theorem of algebra, proved by Gauss. His first name is Carl, and he is from Germany. Okay, good.
You proved everything.
Okay, now look. I already told you, this has quadratic form. Whenever this power is double that power, and that's a constant, it has quadratic form. This is going to keep coming up over and over in this class. Last year, you made U substitution, right? What did you do last year? U equal x cubed. Whatever is here, that's what you let U equal to. But we're past that already. We just go like this, x cubed. Okay, I already gave you the hint, 27 times 8. So 27 and 8 is 216. This one's minus, that one's plus. Oh, and what do we have here? That's a sum and difference of cubes.
No.
Now, when you come out of Algebra 2, you are expected to do sums and differences of cubes at a plus b cubed. A equals b quantity cubed. Okay, let me just test. I'll just call on somebody at random. Callahan. This one.
Okay. X. Do you reverse the sign or do it? Okay.
Just take a guess. 50-50 chance.
Plus.
No.
Minus.
Okay, next. Die.
Oh, plus 30.
He said plus. Oh.
Minus 30. X squared plus. What? No. 9 net.
No. Substitution, Ching. Okay, time out. Let's just pretend we don't know. Let's pretend we don't know. Sock up.
3x plus 3.
Nakasone. Well, first of all, how can it be 3? 3 times 3 is 27. 3 times 3 is 27. 9. Okay, do you want me to write the sums and differences of cubes on the board?
No.
No. This is I'm never going to write it again now. A cubed minus Good thing we're filming. Is equal to a minus b times a squared plus ab plus b squared. Does that look familiar? If you have a cubed plus b cubed, that's equal to a plus b times a squared minus ab plus b squared. Okay, so using what we got up there, okay, how do we factor this up? Lee! Just look at this.
X squared minus 2x plus 4.
Oh, so easy when it's written, yeah? Is that going to be written on your paper when you take the quiz or test? Okay, let's pretend you can't know. Sorry, pretend we don't know anything. Okay, Mr. Park, I only could remember this. I can never remember that. What can you do then? Synthetic division, exactly. So look, you have x cubed minus 27. Isn't that 1, 0, 0, negative 27? You can remember the x minus 3, so you know 3 goes in a box. If you can't remember the other part, just do this. 1, 3, 3, 9, 9, 27, 0. So see, that other one is x squared plus 3x plus 9. Boom. Synthetic division. Holy cow. Holy part backwards. So what are your 6 answers? X equals 3. Does that factor?
No.
No, so use the quadratic formula. So you'll get 2 more from there. Then negative 2. Does that factor? No, but then you use the quadratic formula and you get 2 more, and that's how you get your 6 answers. Oh boy. Okay, is this the last thing? No! Tomorrow we gotta learn probably the most important thing in this whole chapter. Here, I'll give you a preview since we have time. Who said no? Okay? Just pretend, I know that trick, just pretend it wasn't you. What kind of equation is this? This is so you come to class tomorrow. It's like a preview. What kind of equation is that? It's a quadratic equation. How many roots does it have? 2. Yeah, so if you add the 2 roots of a quadratic equation, we just took this test not too long ago, what do you get? Negative b over a. And if you multiply the 2 roots together, you always get 0. Oh, is there something like that for cubic equations and quartic and so forth? Yes. No, there is. And that's probably the most important thing in this chapter. We're going to find out. Yes, there is. So come tomorrow to find out. So tomorrow we have a quiz. Make sure you have your calculator because we need it on 2 out of 5 problems. You're going to have to calculate the 0 and you're going to have to calculate either max or a min. Hopefully you got the keystrokes down right. Yeah. So you play singles or doubles? Ooh. Show you what? Here, the bell rings in 5 minutes. And who else is not coming tomorrow? Soccer? Wait, what time is the game? So you guys are getting on like 9 o'clock.
Wait, for the tennis,
8 hours, right?
oh, you didn't do it for the bonus tennis match, do we have to bring our own racket or give us one?
I can bring extra.
When is the match?
Do with our hands.
You tell me.
When is the class match?
Usually, if you don't, see, you guys, the students always wait till the end of the first quarter and they say, no, I want to play tennis now. I can't play tennis against 60 people. I'm old. I'm over 50 years old. I can barely run. No, actually, I can run like a wounded water buffalo. So what happens is at the end of the quarter, everybody gets all desperate, right? Mr. Park, we gotta play tennis. So usually one class, we just cancel class and we just meet at the tennis court for bonus points. So I just keep playing you against whoever wants to the whole period, and then we just add them up on the board, and we put all 3 classes together, and that's how many bonus points you get for the quarter.
We need all the good people in the time.
Now last year, who did they have last year? Oh, Foy.
You didn't coop.
Darren Foy. Darren Foy beat me 6-0 because he's just too good.
Colin Singh.
Colin Singh,
You didn't coop.
I beat him 2 quarters, but he beat me 1 quarter. Eating cool, come on. Stop choking around. That's a 6-0 right there. Well, do you know, okay, I know a girl tennis players, Nikki Castell. 6-0. Yeah. What do you mean? Of course he knows.
Be here?
Yes. That's because, see, when I play tennis, I don't hit the ball hard. I hit it really soft, but I use mathematics. And that's why people cannot understand, how can Mr. Park win when he's so slow and he doesn't hit the ball hard, but he wins because I use mathematics.
Okay, me and Kiko will play next month.
Monday.
Yeah, we'll Friday, next Friday, after school.
No, cannot, because after school they have, you can't use the courts after school. So that's why it's either going to be lunch or extended, or during class.
Oh, can we go day class?
No! The last week of the quarter, maybe the last day. And for those of you who want to practice, Sarah, you guys know what tennis is? It's played on this thing called a court. Of course, the court is how many feet wide, Okazaki?
56 feet.
No, 78 feet long. And if we're playing singles, Okazaki?
25.
27. However, you have the doubles court, it gets bigger, right? And that, so the width of the doubles court is
36.
36, very good.
How'd you know that?
The height of the net in the middle is 36 inches, but when you go to the edge, the height of the net there
40.
is 42 inches.
Come on, this is just common knowledge.
Yeah, it's like that, yeah. So that's why if you hit the ball close to the middle of the net, you have less chances of making mistakes.
Why doesn't everyone do that?
Because if you just keep hitting back at the person, you know what I mean? You want to try to hit it away from the person. Now I'm going to tell you right now, the hardest part about tennis is serving the ball. So what you're supposed to do is, okay, you're supposed to stand over here, and you're supposed to hit the ball into this rectangle here. If you've never played tennis before, or you have very little experience, that's the hardest thing about tennis, right? It's very difficult. So that's why if you've never played, I mean, you could have played before, but if you've never played like intermediate, JV, or varsity, I'm going to give you a handicap. You can, instead of hitting this ball into this rectangle, you can hit it anywhere in the whole court.
Wait, how big is that square?
You can figure it out right there. So,
It's not proportional. How big is
the whole side.
Oh, no, I mean the smaller one. How big is that?
This one.
Yeah.
Oh, okay, Okazaki, what is this? Well, obviously, this is 13.5 feet. What is that? Quick. It's 21 feet. So what's the area? Quick. Just believe me, it's very difficult. You guys don't even go out to play like tennis in PE or anything? Who played tennis in PE? Did you guys try serving into this box? Hard, right? Cool. No. I want to see it.
This guy named Daniel Pham, he's really good at tennis.
Daniel Pham. Is that the guy in the other class?
State champ.
I know the state champions. He's not one of them.
Oh, shucks. I mean, he was a runner-up for the state champ.
No, I don't think so.
You shouldn't give him a handicap.
Okay, but that's just points taking away from you.
Just don't do it.